Analysis of plane structures. So what is the mean by plane truss? Truss is a structure consisting of rods which are connected only at ends. The points where two or more members are connected are called as joints. Supports in case of truss are provided only at joints. Weight of these members or rods are assumed to be negligible. Trusses are thus formed from a triangle joining three rods. For example, we'll see this triangle. In this triangle ABC, this can be said as a truss when it is composed of three members, means it form a triangle and the members are connected at the joints. Now this structure is stable and rigid. Even after application of external force at the joint, the truss is not going to deform. Where in case of the second example, we see that there is a four-member structure. If we apply external load at support joint C, this member is going to deform. So we can say that this structure is neither rigid nor stable. In order to make it rigid, we have to apply one extra member BD. So when one BD member is added, now this structure is composed of two triangles. So we can say this is a truss and it has now become stable. So to determine whether the structure is statically determinate or not, we can use an equation called m equals to 2j minus 3, where m is equal to number of members and j equals to number of joints. Now there are three conditions. If m is equal to 2j minus 3, means in the previous example we have taken the help of a triangle. In triangle there are three members. Also there are three joints. So on right hand side we can say 2 into 3 is equal to 6. 6 minus 3 is equal to 3. Members are 3 and right hand side is 3. So left hand side becomes equal to right hand side. So when m is equal to 2j minus 3, truss is statically determinate. Whereas if m is less than 2j minus 3, means number of members are less, then structure is not rigid and it is called deficient truss. Whereas when m is greater than 2j minus 3, here number of members are more than required for stability, then such truss is over rigid or called as a redundant truss. Now what are the assumptions to be made while the truss analysis? The members should have negligible weight. Member should have uniform cross section. Members should be connected by pin connections and these should be frictionless connections. Members should carry only axial load, that is the force should be through the member. There are two methods for analysis of truss which are generally adopted. It is the method of joints and method of sections. Now what are the application of truss? Truss can be used as a roof truss to support the sheeting material in case of industrial structures or car sheds. It can be a bridge truss which can use to support the floor or the deck of the bridge, or it can be the part of a electrical transmission tower. Next we have to see one important rule to find out the zero force member. If there are the three members and they are concurrent at a joint, out of which two members are collinear. So here we can see these two are collinear, here these two are collinear, here these two are collinear. Then the third member is a zero force member and other two members will have same force. The important is there should be no any external force acting at this joint. Then only we can say that this third member is a zero force member, whereas the force in the remaining two members will be equal in magnitude, opposite in direction. And one other condition which we have to use is if there are two members connected at the joint and there is a no external force acting on the joint, then force in both the member will be equal to 0. Now we'll see how to solve the numericals of truss using method of joints. First we'll see what is the method of joint. This method involves applying condition of equilibrium to individual joints after isolating them from parent truss. This is generally based on the principle that if the entire truss is in equilibrium, then the isolated joint from the truss will also be in the equilibrium. So what are the steps used to solve the numerical? First step is draw free body diagram of entire truss, then apply condition of equilibrium to find out the support reaction. Then further we can find out if there is any zero force member in the truss Then isolate the joint and draw FBD of the joint. Use these two conditions of equilibrium, summation Fx equal to 0 and summation Fy equal to 0, to find out the force in the members. Whereas at the last joint we can verify what are the forces in the members by using the two conditions of equilibrium.